This video covers the first part on gradient. Sorry for the lines all across the page, but as you've seen in previous videos, it's hard for me to draw straight lines with this program, so I've pre-drawn all the lines I'm going to need in the explanation. Let's get started. Gradient, as you may have learned in other math classes, is a word that means slope, or at least that's the word we tend to use in North America. It's a little bit more of an everyday word, because gradient is also the steepness of the line, and that's maybe easier to understand from the word slope. So gradient is a measure of how steep a line is. So if we take a look at these green and blue lines here, the dark blue one is the steepest of the three, and the green one is the least steep of the three. Over here as well, we have a steep line here down to a less steep line here. But this group of lines is very different than this group of lines, because if we read from left to right, so if we read in this direction, just like we read normal text in English, these are all going up. Think of yourself as a little climber, as a mountain climber, and when I get to this line, I have to go up to get to the top, much more steeply than if I'm at this line and go here. So we call all of these gradients positive. Okay, so a positive gradient is one that if you go from left to right, you're going to be going up the hill. These ones here, even though this is also steep, we consider this negative, because if I start from here, if I start on the left and then go down the line, then I'm not going up, I'm going down, obviously. So these three lines, the pink, purple, and orange one, are all negative gradients. Okay, so positive gradients versus negative gradients. As I already mentioned here, you have different steepnesses. So whatever value I get for the gradient, I would like this line here to have a higher value than this line here, because this one is steeper. So I somehow want the number I come out with for gradient for line 1 to be steeper than line 2. So let's say gradient 1 should be bigger than gradient 2. In these two lines, they're both negative, and we would still want the number, the absolute value of the number, the actual number of line 1 to be bigger than line 2, but of course it will be more negative. So if I write it as an inequality, then it would still be less than, but if I think about gradient 1 is more negative, or a higher negative number, than gradient 2. In case the writing isn't clear, that says gradient 1 is more negative than gradient 2. How do we get that mathematically? Well, in math, the easiest way to calculate the gradient is to think of how the line is changing. So the gradient is equal to the vertical change how much has it changed in this vertical direction divided by the horizontal change. So it's a type of ratio. And the thing about straight lines is that this ratio is the same no matter what part of the line you look at. It would be different if we had an actual mountain that, real mountains, they do things like, Twitch pages didn't like that. Okay, they do things like this and they're changing all the time. But if I just have a straight line like this, if I check the gradient over here, it should be the same as if I check the gradient over here. So it doesn't matter what part of the line we check or we measure, just as long as the ratio between the vertical change and the horizontal change is the same all over. So in math speak, we can put it into a formula like this. M is usually the letter used for gradient. So if you see M, it means slope or gradient. And I use this little Greek letter D, delta we call it, to mean change in. So this is the change in y divided by the change in x. In your textbook, they call this step. It's the step you go up in y over the step you go over in x. And if you grew up in North America like I did, you might have heard this abbreviated as rise over run. It's another way of saying what's the change in the vertical, the rise, how far you've gone up, over how far you've run, how far you've gone in the horizontal direction. So maybe that's an easy way to remember that you divide the y change divided by the x change, because normally in our formulas x always comes first. So here in gradient you have to remember that you do the y divided by the x and not the other way around. If we're going to do this off of 2 points, that's what we're headed to. We want examples where we're given 2 points and we can find the gradient between the 2 points. Then we can also say that the change in y is like subtracting two values, y2 minus y1, divided by subtracting two values, x2 minus x1. So that's the final formula we're going to use in examples later today, is gradient is equal to y2 minus y1 over x2 minus x1. Let's see what that looks like if I take an actual line here and I make a triangle. So maybe best to do it from there to, we'll find 2 points that actually go through coordinate points here and here. And then I can give this an axis. Let's make the y-axis here and the x-axis here. Oh, those aren't bad lines, doing them freehand. Ideally I'd have a ruler. Okay, and then we can label these points. This point here is 1, 2, 3, 4 over in the x direction. So here's another example where x always comes first. And 1, 2, 3, 4, 5, 6, 7 in the y direction. And this point is 1 in the x direction and 2 in the y direction. So I'm going to solve this 2 ways. I'm going to look at the vertical change over the horizontal change, and then I'm going to use this formula as a second method. So the vertical change, if I go from this point to this point, just counting boxes, is 1, 2, 3, 4, 5. So my gradient is going to be 5 over. And now I look at the horizontal change, going from this point to this point. So going along this way, 1, 2, 3. So change in y over change in x is 5 over 3. If I now use the points, let's do this in a different color so we can see the different method, and use the formula m equals y2 minus y1 over x2 minus x1. I first have to know which is my second point, which is my first point. So let's call this point 2, and this is point 1. So this is x2, y2, and this is x1, y1. So my y2 is this point over here, that's 7, minus y1, okay, point 1, y coordinate is this 2. x2 is this point here, is 4. And x1 is this point here, is 1. See how confusing it can be. So I really do think until you get into the habit of doing this, it is helpful to label these right away and then just follow your labels. So x1, y1, x2, y2, and then you don't have to think it through each time, and you can just plug the values in as needed. Okay, so y2 is 7, y1 is 2, x2 is 4, and x1 is 1. And then I solve for it. 7 minus 2 is 5, and 4 minus 1 is 3. So you see, you get the same result. This is the way I would do it if I were given a diagram and could just count boxes off of the diagram, or count units off of the diagram. This is the way I do it if I'm just given the points without a diagram. So let's do one more example where we're just given points. Let's take a look at one that's given in your textbook, and I'll walk you through it. I'm asked to find the gradient between these 2 points. So what's the slope? What's the steepness of the line if I were to connect these 2 points? I could draw it and then count the units, but we're going to practice using the formula here so that we don't always have to draw diagrams. Oops, that's 2. So remember, the formula was y2 minus y1 over x2 minus x1. I'm going to label my points. So if this is point 1, then this is x1, y1. And this is point 2, so this is x2, y2. And then I can plug into the formula. y2 is 4. y1 is negative 2. So I'm going to very, very carefully put that in brackets because I have to watch out with negatives. So if I'm subtracting a negative, then that will eventually become adding a positive. So x2 is 6 and x1 is 3. So 4 plus 2 is 6 and 6 minus 3 is 3. And then I look to see if I can simplify it. That's equal to 2. So the gradient of the line joining these 2 points is equal to 2. Okay, one last comment about totally horizontal lines. If I have a totally horizontal line, then the gradient is 0. It maybe makes sense if you think if I'm a hiker, I have no steepness here. I'm not going down, I'm not going up, I'm staying at the same level, same height, and so my gradient of those kinds of lines will be 0. If I have a line going straight up and down, a vertical line like this, then the gradient is so big, it actually is infinite, and we can't really give it a number because infinity isn't a real number. It's just a theoretical number we use to try to understand things sometimes. So this is infinite, and we actually say here that the slope is undefined. So the gradient has no value. It's so big, we can't define it. Another way of thinking about that is if I look at change in y over change in x, then my y step is huge because I'm changing way up there. If I go, or I could even do it from this point to this point if I don't want to go all the way up the line. So I've got 1, 2, 3, 4, 5, 6. I could think of that as change in y is 6. But my change in x is 0. I haven't gone anywhere in the horizontal direction. So I'm doing 6 divided by 0. Well, that's not allowed with real numbers. We can't divide by 0 because it could be anything. And so therefore we don't have a definition for this in the real number system. It's undefined. Okay, so if you're asked to find the gradient of a vertical line, then say gradient is undefined. Okay, you're ready. You can do the homework for chapter 5, C.1.